Hello friends, so once again welcome to my channel. In our last video we have seen some numericals on direct mapping cache technique. Then today also we'll continue with the direct mapping numericals only. So here is the numerical. The numerical says consider a machine with a byte addressable main memory of 232 2 to the raise 2 to the power 232 bytes divided into blocks of size 32 bytes. That means in your main memory this many number of bytes are there and they are divided into blocks of size 32 bytes. Assume that a direct mapped cache having 1k cache lines. That means in my direct map cache we have got 1k number of blocks and the size of blocks will be same both in main as well as in the cache memory. What is the size of the tag field? That we need to find out, right? So see, the machine is what? The memory is byte addressable. Block size is 32 bytes. Express it in powers of 2. So it will give me the word field length to be 5 bits, right? The number of blocks in the cache is given as 1k. Very simple numerical basically, 1k. That means 10 bits are required to represent a block number. Now see, we have got word field, we have got block field, and we know the total length of the address. What is that? 32. Because in my main memory 2 to the power 32 number of locations are there. So to represent one location, to represent one address, we require 32 bits, right? So size of the main memory is this one. Hence the number of bits in the main memory address is 32 bits. So tag field will be what? Total address minus block field length plus word field length. So 32 minus 10 plus 5 will give me 17 bits. So it was a very simple numerical, the finding the size of a tag field. Then next one more is there. A 16 KB direct map cache, write back cache is there. Write back, you remember, whenever we modify something in the cache, simultaneously we will not be modifying in the main memory. We are going to have a dirty bit that we will keep make it as 1 whenever something is modified in a block during its cache residency. So my cache memory has got 16 KB size and this cache is organized as multiple blocks whose size is 16 bytes. So each block size is 16 bytes. The processor generates 32-bit addresses and the cache controller maintains the tag information for each cache block comprising of the following. So along with my tag bits, the controller is going to store some more bits in a block. It is block wise. So one valid bit is there to understand whether the block is containing the correct data or not. Modified bit, because I am using what? Write back cache. Modified or dirty bit is same. And 2 bits we are using for replacement, which block is LRU and all to know. So my replacement algos are also using some bits, that is 2 per block, and as many bits as the minimum needed to identify the memory block mapped in the cache. That means this part is talking about the tag field coming from my address part, right? So all these are stored in the in a block, means for every block all these bits are going to be stored, right? So what is the total size of the memory needed at the cache controller to store metadata? Metadata means what? This valid bit, modified bit, replacement bit, and the tag bits of my address. All together I am going to store for a block. So what will be its total length? Whatever be the number of blocks into summation of all these will be the total memory requirement to store the metadata. Where? In the cache controller, right? So we'll do it. So see, our block size is what? 16 bytes. That means what? 4 bit will be the word field, right? Next is number of blocks. Total size of cache memory is 16 KB divided by block size. So it will give me what? 2 to the power 10. So 10 bits are required to represent a block in the cache. These two we have got, and we know 32-bit address, so we can easily find out the number of bits in the tag. Just now we have done the same kind of thing in our previous numerical. So see, tag bits is what? 32 minus 10 plus 4 is 18 bits. This is for storing the tag part for getting a match in the cache memory. Along with that, some more bits are there that is given in the question. So we have to include them also in our solution. So size of the memory required to store the metadata will be nothing but number of blocks in the cache multiplied by tag bits, valid bit, modified bit, replacement bit. All this summation into number of blocks in the cache, because all of them we are going to store in a blockwise fashion. For every block they are there. So total length, total storage requirement is whatever is the number of blocks into this summation. So 2 to the power 10 blocks were there. 18 plus 1 plus 1 plus 2 is coming, that is 22 bits. So if I do the multiplication and I convert it into your bytes, then it becomes 2816 bytes. So this is the size of my memory required to store the metadata at the cache controller. Hope this part is clear. Then one more we will do. So that numerical we'll be doing in our next video only. This much is there about the numericals on direct map cache. Next we'll start with next mapping technique, that is fully associative cache. That I will start in our next video. Till then, thank you. And if you are getting from my explanations, then please do not forget to like my videos and subscribe to my channel. Thank you.